Yeah, welcome to the continuation of the STS tutorial on summarization of data and sampling distribution. We finished off the previous lecture. We finished off at measure of central tendencies, where we treated the mean, the median, the mode. And today we are going into measures of dispersion, where we are going to treat the range, the variance, standard deviation, and maybe the semi-interquartile range. This one actually is not so important. It is not so important. I'm going to skip this, but these are very important. They're very important, especially the variance and the standard deviation. Okay. Now, going into the measures of central and measures of dispersion, we've treated measures of central tendencies, where we explained that they tend to find the value that lies at the center of the distribution. This is a normal distribution. Then the value that lies at the center, they tend to find that. Now, this time around, after getting the value that lies at the center, in statistics, we are also concerned about all other values in the distribution. Since this is the value that lies at the center, then how far are the other values away from the value that lies at the center of the distribution? If you are trying to take that into consideration, then you are talking of measures of dispersion. How dispersed are these values away from the center? Remember, measures of central tendencies, the values that tend to lie, the value that tends towards the center of distribution, that is what they get. Now, measures of dispersion gets values that are away from the center, like how far are they from the center of the distribution. So with that understanding, I'd like us to go into the calculation. So starting with range is actually the simplest of them all. Very simple, very simple. And how do you calculate it? Just pick the highest in the distribution, the highest value, then subtract the lowest from it. So let's take our distribution 2, 3, 4, 5, 6 as example. You are told to find the range of this distribution. All you just need to do is pick the highest, pick the lowest, then subtract. As simple as that. You've gotten range. Okay, now let's go to variance. Now this one as well, you have the grouped, you have the ungrouped data. I'm going to start with the ungrouped. So for the ungrouped data, the formula for variance equals, we have different notations for variance, but for now let's go with this. Variance equals, that's for ungrouped data, summation x minus x bar squared all over summation all over n, where x bar is the mean. N is the total number of elements in the distribution. Okay, so let's try to work with that distribution that we have. Then I'm going to draw a table for this, just to keep it neat. 2, 3, 4, 5, 6. Now remember that drawing it in table doesn't make something grouped. No, the fact that it is, if I have 1 2 something here, that's when it is grouped. Take note of that. Okay, so I'm drawing a table just to keep my work neat. Now I need to get the mean. Since this is the formula, I need to get the mean, which is x bar. How do I get the mean? Remember how to calculate mean for ungrouped data. Just simply add everything up, all over 1 2 3 4 5, and that is what, 20 over 5, and that is 4. So 4 is the mean. I just wrote it there. Just feel like writing it there. That's why I wrote it there. So okay, I decided to put it here. Okay, now I need to get x minus x bar. How do I get it? Well, this time, well, it doesn't really matter. You use the absolute value. This thing means absolute value. It doesn't really matter, since you are still going to square it in the end. It doesn't really matter. You can write yours as this. You can write yours as that. It doesn't really matter. Now, for me, I want to put the absolute value. That's 2 minus 4. You know it is minus 2, but since I'm using the absolute value 2, 3 minus this is 1, this is 0, this is 1, and this is 2. So now, like I said, you're squaring it, so it doesn't change anything. 4 1 0 1 4. Assuming it was still minus, it would have been 4. Assuming it was minus, it would be 4. Okay, I already have that. Now I need to sum it, since I need the summation of x minus x bar squared. I've squared it already. Now I need to sum it, and that is 5 plus 5, that's 10. And hen, we all know the hen is 1 2 3 4 5. Okay, so in order to calculate variance, which is in notation form, sigma square equals summation x minus x bar squared all over n, and that is 10 all over 5, and that is 2. Okay, now let me talk of standard deviation once and for all for ungrouped data. Standard deviation standard deviation. Okay, now the standard deviation SD, and the notation is just sigma, equals square root of variance. So it simply is square root of summation x minus x bar squared all over n. Square root is covering everything. So we have square root of 10 all over 5 square root of 2. That is the standard deviation, and that takes us to for grouped data. Now for grouped data, the variance, that's sigma square, equals summation f x minus x bar squared all over summation of f, and the standard deviation will simply be the square root summation f x minus x bar squared all over summation of f. Remember, it covers everything. Okay, let's treat a question. On that. Using that question from the last tutorial, the class, we have 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, and you have the frequency to be 346,246,31. Okay, now we need to get x first and foremost. Since you need x from the question, you need x, and then you need x bar, that's mean. So the x, remember, add this 2 divided by 2, that's 6 divided by 2, 3, this 16 divided by 2, 8, then this is 13, this is 18, and this is 23. Now we need to get the x bar. Do we still remember mean for grouped data? Summation fx all over summation of f. So that means we need fx plus a quick revision 6, this is 32, this is 78, this is 54, this is 23. Okay, and calculating that should be 6 plus 32 plus 78 plus 54 plus 23. That's 193. I hope we still remember that. 193 divided by 16, and that's 12.06. Okay, that is the mean. And in order to make our life very easy, let's just make it 12. Okay, so I put it there, 12. Now we need to get x minus x bar. X minus x bar, that's 3 minus, this time around I'm not writing the absolute value, doesn't really matter actually. Okay, 3 minus 12, that's minus 9. 8 minus 12, that's minus 6. Sorry, minus 4. Sorry, minus 4. Minus 4. This is 1. 13 minus 12. 18 minus 12. 16. 23 minus 12. And that's 11. Sorry, this is 6, not 16. 6. Okay. Yeah. So we're good. Now let's find x minus x bar square. X minus x bar square. So 9 times minus 9 times minus 9, that's 81. 4 times 16, 136, 121. So we need to get the sum. There should still be a tab for f times x minus x bar squared. So sorry, I have to quickly, let's just quickly draw it down here. F x minus x bar squared, and that's 2 times 81, that should be 162. 4 times 16, that should be 64. 6 times 1, 6. 3 times 36. 3 times 36, and that should be 108, and then 1 times, that's still 121. Okay, since we already have that, now let's sum it up. Okay, bringing out my calculator, punching it. That's 162 plus 64 plus 6 plus 108 plus 121. So that's 461. Okay. Then you have summation of x minus fx minus f bar squared to be 461. Since we already have that, we can then calculate the variance, which is sigma square, to be summation of fx minus x bar all squared all over summation of f. This we already know it to be 461. Summation of f is 16. Remember from the previous tutorial. Okay, now punching that on my calculator, that's divided by 16, 28.81. that is the variance. Now to get the standard deviation, remember standard deviation equals to square root of variance, so square root of 28.81, and that should be 5.37. Okay, so that basically is measures of dispersion. That's basically what you need to know under measures of dispersion, and a quick review of the formulas. Range equals to the highest value minus the lowest value. Variance, that's sigma square for ungrouped. For ungrouped data is summation x minus x bar squared all over n, and for grouped data is summation f x minus x bar squared all over summation of f. And remember standard deviation, equals to square root of variance, grouped or ungrouped. So that means for ungrouped is square root of summation x minus x bar squared over n, and for grouped equals to summation f x minus x bar squared all over summation of f. Okay, that concludes the tutorial on measures of dispersion. We're going to continue with sampling distribution. Thank you for listening. I remain Olasende Faith.